Good morning, my name is Mayanne. I'm the Regional Manager for Bioflitro. Today we are out in Royal City at Royal Dairy, Washington with Austin Allred, the owner of Royal Dairy. So Austin, do you mind telling me a little bit about what you do here?
Yeah, we milk cows. We got about 5,000, just over 5,000 cows milking. Most of those cows are in freestall barns that we flush to clean those pens with. The other 40% live in the open lots. We have a primary separation with a centrifuge, and then after that, last few years, we've just the effluent of that centrifuge has been trucked onto thousands of acres annually in order to get rid of that water. So we've been looking for a system for a few years now to clean that water up so that we can put it through our circles and not deal with the high nutrients in that water and not have to truck. So that's kind of what brought us to the Bioflitro.
Mm-hmm. And so Bioflitro, what we do, we're standing in front of one of ours. It's actually currently the largest dairy system, and it's the largest system right now operating in the U.S. for Bioflitro. Bioflitro is a global company. We have more than 140 plants operating worldwide. We've treated about 32 billion gallons to date. And this system out here, it's doing 200,000 gallons per day, and it's 81,000 square feet. So you can see 3 modules out there. And what we do is we do wastewater filtration. We provide secondary filtration, and we do a combination of physical filtration as well as biological filtration. So ultimately what you can see is an irrigation system above this. The BIDA system is what it's called. And so from top to bottom there is a layer of wood shavings, then there's a layer of river cobble down below. Then there's drainage basins or about plastic pallets that are just maintaining about a 2-inch space at the base. And these vent pipes connect down to the air chamber down below just to provide passive aeration. The structure is completely sealed at the base, so it's kind of like an open top pool or concrete basin, you could say. And then so when the wastewater is applied via the irrigation system, it'll percolate down through these physical barriers, which provides natural filtration. But in addition to that, what we've done is we've inoculated the system with worms, microbes, and bacteria. It's industry specific, and so the worms will target the solids in your wastewater, and as they're moving throughout the system looking for the solids to eat, they're creating air channels as they're moving, so they're aerating the system, and air is typically a very important factor in wastewater treatment. And what they're also doing is they're maintaining a stable environment so that the bacteria and microbes can form what is called a biofilm, and this biofilm grows throughout the wood shavings and on the rocks. And it's just billions of colonies of microbes and bacteria that capture, retain, digest, and remove contaminants from the water. So this entire process here lasts only 4 hours. So within 4 hours, Austin's able to remove more than 90% of total nitrogen, more than 90% of total suspended solids, and more than 90% of total phosphorus, I believe was what you were averaging.
Yeah, for the pilot.
For the pilot, correct. So Austin also ran a pilot for 2 years. He didn't believe us when he first met us. I mean, you can talk about your experience when you first heard that worms could do this.
Yeah, so this little square here, which is now a pre-treatment for the water, was our pilot for the last 2 years. Essentially doing the exact same thing that the full-scale system is doing, but in a smaller scale, so that we could test the system, the biological system, with our water, the effluent of our centrifuge. So we've been running up to about 10,000 gallons a day on that little system for the last couple of years, and just analyzing the water going in and the water going out, and seeing the effect that the Bioflitro had on it. And it's been impressive. It's cleaned the water. All the technology and the science I don't necessarily understand, but what's important to me is that the water going in was dirty and the water coming out was clean. And as a result, with this bigger system, we'll be treating about 200,000 gallons a day, which will handle all the excess water that our dairy currently puts out. And so we will be able to have we have about a 25 million gallon lagoon over here, and that lagoon will be full of this clean tea water, which then will be directly pumped onto circles. And really all we need is a couple 300 acres of circles to handle up to 45, 50 million gallons a year. Whereas before it was 4,000 acres that we had to haul with tanker trucks to get rid of that 50 million gallons. So that's mostly where we see our return on this investment, and that's why cleaning the water is so significant to us, because we can get those trucks off the road. We can get rid of the nutrient-rich water and have a clean irrigation water on our dairy, which from there's a lot of positive effects between smell and the emissions of different gases. So a lot of advantages coming as we are able to clean our water on a daily basis and store clean water, and then irrigate with clean water versus store dirty poop water and truck it onto fields.
So in addition to that, one of the good things is also, and typically in wastewater, you generate a sludge, which is like a toxic, somewhat solid that you need to dispose of. But here, what are you generating instead?
So on this right now you see the wood shavings. This is all wood shavings. As you can see on the system, that's wood shavings that has been treated with the effluent of the centrifuge, that nutrient-rich water. So over time, the worms will slowly turn this top 2 foot into worm castings, which is a very valuable soil amendment. And so through that system, so on an annual basis, we will harvest a foot or 2 of worm castings and be able to then sell those and have some more positive benefits from the system.
So it helps Royal Dairy, of course, be not only, like Austin was saying, very efficient in their water, but it also reduces how much waste they're generating. So by converting what was otherwise wastewater and would have been wastewater and sludge, you now get reusable water that Austin's going to demonstrate on his garden over there, but also able to irrigate on smaller acreage. And he's also generating worm castings, which he can then use to fertilize his own crops. So it's a zero waste, closed cycle system as well. Energy efficient. And I mean, everyone wants to know, well, how difficult is it to operate?
Well, it's probably one of the most attractive pieces that got me interested in the system was the simplicity to operate. The sprinkler, the irrigation system, the pumps, those are all things that I understand as a dairy operator and dairy farmer. Some of the different systems, the DAF, the polymers, the ultrafiltration, the reverse osmosis, those things were a lot more complex and a lot more difficult for me to understand personally. So the simplicity of this system is one of the most attractive pieces to it. And like Mayan was saying, it is really a huge advantage for us here to be able to track the water that we utilize and to be able to really sustain that and turn that into irrigation water and really have a zero loss on our water usage.
I want to wait for it to stop.
I'll do it.
Are you sure?
Come on, Mayan.
Apparently they're in the mounds. They're more in the mounds. They're hiding from the show, apparently. There you go.
Can you zoom in on that, or you want me to bring you some? So this would be top layer. Mayan can explain better what's going on there.
So you can see a ton of obviously earthworms that you have growing. I don't know if you can get. You can see the earthworms here that are growing. And so this system just started up about a week or 2 ago. So these are still juvenile worms. They're still getting adapted to the water. So the most common worm found in this system is the California redworm. So it's all natural, local worms. They're non-GMO or anything. And so what you can do is that it's an industry-specific mix. So the amount of worms that you find in a system will depend on how much food essentially you place at the table, and the types of worms that you find in the system is also industry-specific. So we also service wineries, food processors, we handle municipal waste, we do slaughterhouses, aquaculture. The mix and variety of worms, microbes, and bacteria vary throughout those industries, as well as the concentration. So a lot of people, they'll look at our systems and say, you're a box of worms, what makes you special? Ultimately, we are a biotechnology firm, and so what we can establish in these systems is a population density of worms of up to 12,000 feet per cubic yard. To give you an idea, in extremely fertile soil here in central Washington, you might find 300 to 400 worms per cubic yard. So with that high maximum density of worms, you're also being able to achieve and maintain a high density of microbes and bacteria, which is what provides us with the digestive powers. So thanks to these little guys, we get treated water in 4 hours.
As a dairy farmer, we get the question all the time, how many cows do you milk? Kind of gets annoying, but a friend of mine, the local dairy farmer here, Kelly Callahan, sent me a text the other day and said, one day the question's going to be how many worms do you have, not how many cows do you milk. So one day, maybe.
We'll have to count.
We'll have to count the worms, and that'll be the new question.
So you can say that Austin employs millions of worms and bacteria. He gives them food and pension.
Yeah. Yeah, that's their salary, food and pension.
Thanks so much for joining us. If you have any questions, please leave them in the comments down below, and we will be back at 2 p.m. Pacific time to answer them.